Hey everyone, Rob here from Rising Edge Industries, and in this quick take video we're going to go over the run mode. So first thing we'll do is launch our configuration application, and we've got our usual data recorder set up here on the webcam. One of the live ones will be here. You can see the blinking LED. The internal logic or the data engine or digital engine in the product is idling and ready for a trigger or configuration commands. It's also charging. You can see it's almost fully charged when we connect to the unit. We'll connect to 20. We have 2 units connected to the workstation. We use one for most of the demo, and then we'll use unit 19 to do a data capture. It's off-screen connected to a signal generator, but we'll use that for one quick data capture in a little bit. The fuel gauge shows about 92% battery capacity and charging here, and the blinking percent symbol shows a healthy connection over the USB link. And so the easiest way to explain, there are 2 run modes in this device, and the first run mode, that's the simplest, is called OneShot, and the second run mode, which is more advanced, is called burst mode. And this video will just go over the OneShot mode, and the easiest way to do this is to just show a simple timing diagram. And so if you've looked at any of the video content discussing trigger capabilities or the general overview, longer videos, we talked about the triggering mechanisms for the DR500 line. And so here's a little graphic. There are actually 3 trigger functions or trigger inputs to these data recorders. There's the USB command, which is the start sampling here. The second one is a discrete input, rising or falling edge, and so that's a discrete single-ended signal. The edge selection's here under trigger settings in the graphical user interface, and this is connected into one of the PCB tongue headers that's exposed. It's actually header right here on the bottom board, so you just wire your signal into there. The third option, these are all ordered together, so any one of these, the first one in will trigger the data engine to start data acquisition. The third one is boot trigger, and we'll do a quick example of that, but this is a way to configure the data recorder to auto trigger itself on its next power up. So for example, if this needs to be embedded in a system and powered up at a later date, customers can configure the device, test it, and before it gets embedded in the larger system that's under test, you just erase the memory, reset the recorder, make sure it's going to power up and the memory's clear. Check out our memory erasing quick take video where we discuss that in a little more detail. But once you go through those steps, you just check the boot box here for boot trigger, and when this is part of the configuration, so for example, if you wanted to change gains and an extended run for 600 milliseconds, and then check this box, when you do set config and then get config, you'll see you're in OneShot mode and boot trigger is true, or up here boot trigger was false. And this boot trigger means that the data recorder will power up, configure itself, and then automatically trigger itself right after its power up configuration. So we'll do a quick demo of that on the webcam as well in this video. So to get back to the diagram, OneShot mode is pretty simple. It's fairly self-explanatory. So you provide one trigger event. You can see here the data engine. There's no data acquisition going on. And so this idle mode is exactly what you can see in the webcam here. One blinking LED, the busy LED is off, and the triggered LED is also off. So there should just be one blinking LED. The bottom tongue has 2 LEDs, a charge light, and then a power status good. Those can be on. If the battery doesn't need to be charged and you're at 100% here, or over 95% when you connect over USB, then the LED that indicates battery charging won't be illuminated. So when you submit a trigger event, any one of these three, the data engine changes from idle to data acquisition. The busy LED comes on and stays on for the duration of the data run. Then after the trigger event, the engine transitions back to idle mode, and you'll see the busy LED go off, and right next to it a triggered LED will turn on, just to give the customer a visual indication that the device has been triggered. And the purpose of that is to let you know that to use this again for another data capture, the memory needs to be erased from here, sector erase or full erase, and then reset. So it's a pretty simple sequence of steps and timeline. There's one other functionality to note. It's the stop command from the UI. So you can stop a data acquisition run at any time by submitting this USB command stop, found here in the GUI stop, and we'll do a demonstration of that as well. So for right now, we'll do a quick data capture. We'll connect up to the other device. That's just going to record a sine wave from our signal generator here on the bench. That's going to be serial number 20. So let's see, select 20, open, get configuration. Oh, that's actually going to be serial number 19. Relaunch, reconnect, open serial number 19, get configuration. So we'll erase the recorder. We're just going to do no gain, simple default settings. The only thing we changed was we set in the configuration the channel to record was channel A3, 1, 2, 3, 4. So our signal generator is connected to channel 3. We'll reset. Always make sure the memory is erased. Now, as we saw here, once you submit a trigger event to the device, data capture starts here and runs for the set amount of time here in runtime. So the post-trigger runtime here, 60 milliseconds for this example. You can set that to in milliseconds or seconds. And so we'll see we run here in our data acquisition state for 60 milliseconds. So reset, we'll submit our trigger, download. Download's pretty quick. We'll grab our data utility application and we'll actually relaunch this. Move the console off and go check our folder that holds our data files. It's serial number 19. The voltage, and this was the latest data 3. That's what we just recorded. So we see our sine wave here from unit 19. This is unit 20. The unit shown in the webcast is 20. So this is just an example to show what we would expect from the recorder and to just run through a simple download. So now I'll connect back to serial number 20. So we'll select the unit we want, connect, get configuration. We actually won't pull down a data file from this device since the input headers aren't connected to any test equipment at the moment, but what is important to show is we'll run a 1-second test here. So we can see our run duration is 1 second. So what you want to notice is here the LED indications that will happen right now. We're blinking. When we click the start button, you'll see the busy LED and the triggered LED come on. So all three are on after 1 second. The busy LED shuts off. The blinking LED comes back to indicate idle mode, and the outside LED indicates that the device has been triggered and needs to be reset before another data capture. So it's pretty straightforward, but just to just to be explicit and step through this, this is the top timing diagram above this red dotted line, the standard run. So that's what just happened. So now next we'll increase the runtime for the data capture, and we'll show the issuance of a stop command via USB can shut the engine off. So to do that, we'll just, and because this is a longer duration, you would actually want to erase more than 2 sectors. So if we were actually capturing data here, we would erase 15, 20, 30, 40 sectors, depending on how long our runtime is. See some of our other quick take videos for a discussion of memory erasing. In this example, we're just going to run for 6 seconds. And so we'll let this run complete. You can see here in the webcam that the LEDs will illuminate for 6 seconds. Oh, oops! I didn't set the configuration. So you can see the configuration was set for 1 second. Now I've got the configuration set for 6 seconds. You'd want to increase this to run for 6 seconds, probably to something more than 10 sectors. This is going to be 5 megs. Again, see the quick take video for memory erasing. It goes into a little bit more detail, and I explain how that works. So now we're ready to go. Memory's erased. This is a standard procedure for one-shot mode operation. So now if we kick off the data engine, you can see we'll go from blinking to our illuminated LEDs. Here on the tongue, they'll stay illuminated for 6 seconds. The center LED will shut off. The status LED will begin blinking to indicate idle mode. The third LED that indicates whether the device has been triggered or not and needs to be reset will stay illuminated. And so if we reset to show the function of the stop command in one-shot mode, we just do this again, but instead of letting it run, we will cancel the data acquisition in less than 6 seconds. So while the data recorder is acquiring data and writing to memory, we'll stop this. So we'll start the recorder now. 1, 2, stop the recorder. So you can see issuing that stop command over USB. It stops the data acquisition. The engine returns to an idle state indicated by the LED, and you still see the device has been triggered, indicating the user needs to reset and erase the post-trigger memory for another data run. And that's it. That's it for one shot. It's really just trigger, acquire data. The second data capture with the stop event shown here. So TR was just 2 seconds. We issued a USB stop command, and it cut the data acquisition period off short. Return the engine to idle mode, lets the user know that data has been acquired, it needs to be reset, but it's back in idle mode, ready to accept commands and communicate with the customer. And so the last feature we want to point out, we'll run through this quick for this quick take video, is the boot trigger capability. So this allows customers to configure and erase the device, then power it down and have the device auto trigger itself on the next power up. Keep in mind there's a power enabled jumper here that you can bring out through an umbilical or a bulkhead. So these devices can be embedded in a larger system or device under test and stored for a period of time with power off, and then when the device under test is ready to operate, upon the opening of this jumper, the device will power up, and the auto trigger capability allows the device to run fully autonomously if customers have no access to any of these interfaces here on the front of the recorder. So we'll stick with our 6 seconds. We'll check the boot trigger box, set our configuration, reset, and we can see our boot trigger is true. So now we're ready to go. So this device we will short this out with a screwdriver here. So our power enabled jumper is, we've got a 2-pin header installed here. When I short this out, it will power down the device. You'll see the blinking light stop. You'll hear it disconnect from USB. The device is powered down. So now when I release this and open this connection, the device will power up and auto trigger itself. So you'll see this on the status LEDs, that power up configuration LEDs on. It has a wait period, blinks for idle state, in idle state for a second or two, and then auto triggers itself. So that was a 6-second data acquisition period where the LED was on. You could see that was 6 seconds of our data capture. It finished, automatically goes back to idle mode, and then has the previously triggered LED to indicate to the customer that the device has been triggered and needs to be reset, and it needs to receive a memory erase command before any more data is captured. And this won't auto trigger itself twice. It's one and done design. So if we power the unit down again, allow the unit to power back up, it's just going to run in idle mode just like normal. So this boot trigger you only get one shot with the boot trigger. If it power cycles a second time, it's just going to power up and wait for direction over the USB link, or for a discrete trigger event. So that's it for this quick take video. This pretty much covers OneShot mode. Check out our other quick take videos, and to see burst mode, which is slightly more advanced, we've got a quick take video on that. So thanks, and we'll see you on the next one.